Imagine this. You're in a really busy coffee shop, right? Loads of chatter, coffee machine hissing, just a million distractions.
Yeah.
Yet somehow you easily tune into your friend's voice, catch every single word. Or maybe you're stuck on a tricky problem, hitting a wall, and then boom, suddenly, maybe while you're washing dishes, the answer just clicks.
Right, that aha moment.
Exactly. Your brain does these amazing things every day, and, well, you probably don't even think about the complex stuff happening behind the scenes.
It feels like magic sometimes,
Yes.
doesn't it?
Yeah.
But it's not just random. These are, the everyday wonders of your brain system. We call them cognitive processes.
Cognitive processes, okay.
Yeah, these are the higher level functions letting you become aware of and understand and, well, interact with everything around you.
And that's exactly what we're diving into today. We want to give you a kind of shortcut, not just to know what these processes are, but to really get how your mind works in these fundamental, sometimes really surprising ways. From how you focus, how you learn, how you solve problems.
Yeah.
Yeah, get ready for some insights into your own brain.
We're going to sort of pull back the curtain on core things like attention, perception, thinking, and learning. Reveal the hidden gears behind your everyday mental life.
Like decoding the brain's secret playbook. I like that.
Yeah.
Okay, so let's kick off with the brain's main filter. Attention. I mean, just stop for a second. Think about all the sensory stuff hitting your brain right now.
Oh, yeah. It's a flood.
Sounds, sights, how your chair feels. It's overwhelming, really. You just can't consciously process everything.
Absolutely not. And that's why attention is so selective. It has to be.
Yeah.
Guilford, a psychologist, put it nicely. It's focusing on one or few objects, persons, or situations from among many from the field of awareness.
So you're constantly filtering, deciding what gets through the gate into your conscious mind and what stays out.
Exactly. Filtering out the noise.
So what actually decides where that mental spotlight lands?
Well, it's a mix. You've got objective factors,
Yeah.
things about the stimulus itself.
Like how loud it is.
Yeah. Intensity, size, if it's moving, repeating, a loud horn or a bright flashing sign. They tend to grab your attention whether you want them to or not.
Makes sense. But there's more to it, right?
Oh, definitely. They're the subjective factors, which are all about you, your interests, your goals right now, your mindset, your attitudes. These are huge.
So if I'm looking for my keys, suddenly every shiny object looks like a key for a second?
Kind of, yeah. Or if you're searching for a specific book in a library, your brain tunes out thousands of other perfectly good titles because they're not relevant to your goal.
Okay, now this spotlight. You mentioned it has limits. Let's talk about the span of attention. Trying to memorize a new phone number all at once is hard.
It really is. That's because our span is pretty limited. For most adults, it's like 7 or 8 separate pieces of information, maybe plus or minus a couple.
7 plus or minus 2. The magic number.
That's the classic idea, yeah. And it's why things like postal codes or license plates are often chunked into shorter segments. They're designed around this cognitive bottleneck.
But you can get better at it, right? Like with practice.
You can. Practice helps, and also techniques like chunking, grouping info into meaningful bits. Like remembering a phone number is 3 small groups, not 10 single digits. That effectively stretches your span.
Okay, that's useful. Then there's the opposite. Distraction of attention. We all know this one. Trying to work, phone buzzes, neighbors' loud music.
Yep, those are external distractions pulling your focus. But, often the biggest distractions are internal.
Like what?
Feeling sick, bored, just not interested in the task. Your mind wanders, your physical state, your mood, how engaged you are. They all affect how easily you get sidetracked.
Okay, now here's one that I find fascinating. The myth of division of attention. You see people multitasking all the time. Reading while eating, knitting while watching TV. It looks like they're doing 2 things at once.
It really does look that way. But the truth is, our brains aren't really wired for true, simultaneous, equal attention to 2 complex tasks.
So what's actually happening?
It's mostly rapid task switching.
Yeah.
One task, usually the more practiced one, is running on autopilot, almost mechanically. The other gets the main focus. Your brain is just flicking back and forth incredibly quickly.
So trying to really focus on 2 things, like reading a dense article and following a complex conversation, that doesn't work well.
Not efficiently, no. You'll make more mistakes, you'll be slower, probably feel more confused. For deep, focused work, single tasking is usually the way to go.
Good to know. And finally, attention isn't steady. It fluctuates.
That's right. It's not a laser beam locked on target. It naturally oscillates. You can't maintain peak focus on one single thing for very long without tiny shifts.
Like in a lecture, you're listening, but maybe your mind briefly jumps to your friend, or a noise outside, then snaps back.
Exactly. Totally normal. Often it's just mild fatigue or, other things catching your eye for a split second. Understanding this is key. Trying for unbroken concentration might be counterproductive. Short breaks or switching tasks briefly can actually help maintain overall focus.
Wow, okay. So attention filters the world. What happens next? How do we make sense of what gets through?
Now we're moving into perception, giving meaning to the world. This is where raw sensation gets interpreted. It builds directly on attention.
So it's more than just seeing or hearing.
Much more. Think about language. If someone speaks in a language you don't know, you sense the sounds, you hear them, but you don't perceive the meaning. If it's your native tongue, bam, meaning assigned instantly.
Because of past experience?
Precisely. Perception is basically sensation plus meaning drawn from your mental library, your past experiences.
How does that meaning assignment actually happen? You mentioned 2 ways.
Yeah, 2 main routes, often working together, top-down versus bottom-up processing. Top-down processing is when your brain uses its existing knowledge, the context, your expectations, to interpret incoming sensations. It starts from the top, your concepts and knowledge.
Can you give an example?
Sure. Think of an ambiguous symbol, one that could look like a letter B or the number 13.
Okay, I can picture that.
If you see that symbol surrounded by letters, like A symbol C, your brain will almost certainly perceive it as B. It uses the context, the sequence of letters, your knowledge of the alphabet, to resolve the ambiguity.
Got it. Using the bigger picture to interpret the detail.
Exactly. Now, bottom-up processing is the reverse. Your perception is built directly from the sensory input itself, starting from the bottom, the raw data.
So using that same B13 symbol.
Right. If you see it surrounded by numbers, like 12 symbol 14, your brain analyzes the lines and curves, and based on that raw data fitting the numerical context, interprets it as 13.
So context can completely change what we perceive, even with the exact same visual input.
It absolutely can. Our expectations and the surrounding information heavily influence perception.
Our brains are also trying to organize everything, right? Not just see random dots and lines.
Yes, exactly. We have this innate drive to organize sensations into meaningful wholes or patterns. This brings us to the laws of perceptual organization, often called the Gestalt laws. Max Wertheimer was a key figure here.
Gestalt, meaning whole or form in German.
That's right. These laws describe how our minds tend to group things. They're fascinating because they reveal these automatic organizing principles.
Okay, like what?
Well, there's the law of proximity. Things that are close together are perceived as belonging together as a group.
So if I see 8 dots, but they're arranged in 4 pairs close together, I see 4 pairs, not just 8 dots.
Exactly. Your brain automatically groups the nearby ones. Then there's the law of similarity.
Similar things get grouped.
Yep. If you have a grid of alternating circles and crosses, you'll tend to see vertical lines of circles and vertical lines of crosses, rather than horizontal rows of alternating shapes. The similarity overrides the proximity in that case.
Okay, makes sense. What else?
The law of continuity. We perceive stimuli as continuing in the smoothest path. If 2 lines cross, we see 2 continuous lines intersecting.
Not 4 separate shorter lines meeting at the center.
Right. Our brain prefers the continuous interpretation. And then there's one I find particularly cool. The law of closure.
Closure, like closing maps.
Exactly. Our brain automatically fills in missing information to perceive incomplete figures as complete, meaningful objects. If you see an outline of a triangle with a small gap in one side,
You still see it as a triangle.
you do. Your brain closes the gap. It's like it wants to make sense of the world, creating coherence even when the input isn't perfect. Think about logos that use negative space. Cleverly, they rely on this principle.
Fascinating. Okay, so we attend, we perceive. Now let's talk about thinking, the inner world of manipulation. What exactly is thinking?
At its heart, thinking is a mental activity. It involves using different cognitive bits and pieces, images, concepts, language, to manipulate information inside your head.
Manipulate how?
To solve problems, to reason things out, make decisions, form judgments. It's that internal conversation or process you have.
And it's private, right, internal. When I'm thinking, I'm not necessarily doing anything physical.
Correct. You're often running through various actions symbolically, as psychologists say, like playing out scenarios in your mind, testing ideas without having to actually perform them in the real world. It's like a mental sandbox.
What are the key building blocks of thinking?
Well, one fundamental element is mental representation. or imagery. This is your ability to create a mental picture of something that isn't physically there right now.
Like if I ask you to imagine a specific beach, you know?
Exactly. You can conjure up the sights, maybe the sounds, the feeling of the sun, even though you aren't there. You're accessing a mental representation.
Okay. What builds on that?
Concepts. Concepts are your internal representations for categories or classes of things. They're formed by noticing similarities and differences.
So a child learning the concept of dog.
Right. They see several different dogs, notice they share features, 4 legs, fur, barking, and abstract that into the concept dog. Concepts are crucial building blocks for organizing knowledge.
And then you mentioned schemas. How are they different?
Schemas are like higher level frameworks. They organize knowledge about related concepts and how they connect. If I say restaurant, your restaurant schema gets activated.
And that brings up concepts like tables, waiters, menus, food, paying the bill.
Exactly. And the relationships between them, like you usually order from a menu before you get food. Schemas provide context and structure for understanding situations.
And underpinning all of this.
Language. Language words, grammar is the primary system of symbols we use to represent and manipulate all these mental representations, concepts, and schemas. The word cat symbolizes the whole concept of a cat. It's fundamental to complex human thought and communication.
Okay, so those are the elements. What about different types of thinking? Problem solving seems like a big one.
Huge. It's the process we use constantly to navigate challenges, big or small. Finding your lost keys, figuring out a complex work issue, deciding what to have for dinner.
Is there a typical process for solving problems?
There often is, yeah. A key first step, maybe the most crucial, is defining the problem accurately.
Why is that so important?
Because if you misunderstand the problem, you'll chase the wrong solutions. Think about a doctor misdiagnosing an illness that the treatment won't work. Correctly identifying the core issue is paramount.
Okay, define the problem. Then what?
Then you generate alternative solutions. Brainstorming, basically. For most problems, there isn't just one answer. If you have a deadline crunch, you could work late, delegate, ask for an extension.
Get multiple options on the table.
Right. Then you select the best solution. This often involves reasoning, weighing the pros and cons, maybe thinking about what worked before.
And finally,
you implement the chosen solution and follow up. See if it actually worked. And if not, you might need to go back, maybe redefine the problem, or choose a different solution. It's often a cycle.
Makes sense. What about creative thinking? That feels different.
It is, in many ways. Creativity isn't just for artists. It's about seeing things in new ways, finding hidden patterns, connecting unrelated ideas, generating novel and useful solutions. Scientists, entrepreneurs, designers all rely on it.
Does it have stages too, like problem solving?
Yes, though they can be a bit less linear sometimes. It often starts with preparation.
Gathering info.
Yeah, immersing yourself in the problem or domain, learning everything you can, brainstorming initial ideas, maybe trying things out, like a musician experimenting with melodies.
Okay, what comes after intense preparation?
Often, surprisingly, a period of incubation. This is where you might step away from the problem, maybe because you're stuck or frustrated.
So you stop thinking about it?
Consciously, yes. You might focus on something totally different, go for a walk, sleep on it, work on another project. But here's the interesting part. Your unconscious mind often keeps mulling it over, making connections below the surface.
And that leads to
the magic moment, illumination, the aha or eureka moment, that sudden flash of insight where the solution just appears, often when you least expect it.
Like the answer popping into your head in the shower?
Exactly. It often feels effortless and comes with a rush of excitement. Seemingly unrelated ideas suddenly click together.
But is that sudden idea always right?
Not necessarily perfect right away. That's where the final stage, verification, comes in. You need to test, refine, and elaborate on that insight. Does it actually work? Does it solve the problem? This might involve careful analysis, experimentation, or further development.
Preparation, incubation, illumination, verification. Fascinating process.
It really is. It shows that sometimes the best way to solve a hard problem is to stop trying so hard, at least consciously for a while.
All right, let's move to our final major topic, learning. Permanent change through experience. How do psychologists define learning?
The standard definition is something like a relatively permanent change in behavior that occurs due to experience or practice.
Okay, relatively permanent seems important there.
It is. It distinguishes learning from temporary changes. For example, if someone's behavior changes because they're tired or, say, under the influence of a drug, That's not learning because it's temporary. Once the fatigue or drug wears off, the behavior reverts.
But learning to ride a bike or speak a language, those changes stick around.
Exactly. Those result from experience and practice, and they lead to lasting changes in your capabilities or behavior. That's learning.
So how do we learn? What are the main processes?
Well, one of the most foundational is classical conditioning. This comes from Ivan Pavlov, the Russian physiologist.
Ah, Pavlov's dog.
The very same. His work showed that learning can happen through association. When two stimuli are repeatedly paired together, the response to one stimulus can become triggered by the other.
Like the dog's learning to salivate just at the sound of the bell because the bell always came before food.
Precisely. And it happens to us too. A child might start feeling anxious just seeing the dentist's office, not only when they get a shot, because they've associated the place with the unpleasant event. Many emotional responses are learned this way.
Okay, association. What's another way we learn?
Operant conditioning, mostly associated with a B.F. Skinner. This focuses on how the consequences of our actions shape our future behavior.
So, rewards and punishments.
Essentially, yes. Behaviors followed by positive consequences, or rewards, tend to be repeated. Behaviors followed by negative consequences or punishment tend to decrease. Skinner showed rats would learn to press a lever if it delivered food.
And in human terms.
We study hard to get good grades, positive consequence. We stop speeding after getting a ticket, avoiding a negative consequence. Our environment is constantly shaping us through these reinforcement and punishment contingencies.
Are those the only ways? Just association and consequences?
No, definitely not. There's also learning by cognitive processes, highlighted by researchers like Edward Tolman. This was a big shift.
How so?
Tolman showed that learning can happen internally, cognitively, even without immediate rewards or punishments. His rats, for instance, seem to create cognitive maps, mental representations of mazes, just by exploring them, even when there was no food reward at the end.
So they learned just for the sake of learning or understanding the layout?
It seems so. This suggested that learning involves internal mental processes, not just automatic stimulus response connections. We form mental models.
Interesting. What else?
Jean Piaget's ideas about assimilation and accommodation are also key to understanding learning, especially cognitive development.
How does that work?
Basically, when we encounter something new, we first try to assimilate it into our existing concepts or schemas. Like a child seeing a horse for the first time might call it a big doggy, fitting it into their existing dog concept.
Okay, trying to make it fit what they already know.
Right. But if it doesn't quite fit or they learn distinguishing features, they need to accommodate. They might modify their dog concept or, more likely, create a new concept for horse. This constant process of refining existing ideas and creating new ones based on experience is fundamental learning.
Assimilation and accommodation, constantly updating our mental models.
Got it. And finally, a huge amount of learning happens through learning by observation, famously studied by Albert Bandura.
Just watching others.
Exactly. We learned countless skills, behaviors, attitudes, and even ways of thinking simply by observing other people models and then imitating or adopting what they do.
Like how kids learn to talk or walk or use utensils?
Yes, those basic skills, but also much more complex things. Social norms, how to react emotionally in certain situations, problem-solving strategies, even fears can be learned just by watching others. Bandura called it observational learning or modeling. It's incredibly powerful.
Wow. Okay, so we've covered a lot. Attention filtering, perception interpreting, thinking manipulating, and learning changing us through experience.
It's quite a journey through the mind, isn't it?
It really is. So, wrapping this up, what's the big picture for someone listening? What does understanding all this mean for, everyday life?
Well, the first thing is seeing how interconnected it all is. Attention, perception, thinking, learning, they aren't separate boxes. They're constantly interacting, influencing each other in this incredibly complex dance that lets us function in the world.
Right. It's a whole system working together.
Exactly. And understanding these processes isn't just like academic trivia. It gives you real insights into yourself. How do you learn best? Why do you get distracted by certain things? How could you approach problems more effectively or boost your creativity?
So it's like getting a user manual for your own brain, in a way.
That's a great way to put it. It gives you tools and awareness. Knowing about attention span might help you structure your work better. Understanding incubation might make you less frustrated when you're stuck on a creative problem.
So here's a final thought to leave everyone with. As you go about your day, just notice these things in action. Notice your attention shifting. Notice how context changes your perception. Maybe reflect on how you solved a recent problem.
Yeah, and consider this. Knowing that your brain is constantly doing this filtering, interpreting, connecting, how could consciously using one of these principles change things for you?
Like, what if you deliberately used incubation for that tough work challenge? Or consciously checked if context is biasing how you see a situation?
Exactly. How might that awareness change how you experience the world, how you interact with others, and maybe even how you approach learning something new, something to think about?